Hey, it's Mr. E here. Our aim for this video is how do we apply the properties of logarithms to rewrite logarithmic expressions in equivalent forms. Alright, so to begin, we need to know what the properties of logarithms are, and we got three properties: product property, quotient property, and the power property. So in the product property, we see that the expression log base bm plus log base bn could be rewritten as log base b product of m and n. Now, if you're wondering why that is, recall that when you are multiplying two exponents and they have the same base, so you got b to the n times b to the m, you can rewrite that as b to the n plus n. In the quotient property, we have log base bm minus log base bn rewritten as log base b m divided by n. So that's a quotient. And again, this also relates to properties of exponents. If you recall, b to the n divided by b to the m, that's equal to b to the n minus m. The power property states that r log base bm could be rewritten as log base b m to the r. So in the power property, the coefficient r is being moved and made the exponent of m. Okay, so let's put these properties to practice. Here's our first example. Let's get rid of that. Write as a single logarithm 3 log base 520 minus 2 log base 510. So to begin, we're going to use the power property. The power property is going to allow us to move that 3 and make it an exponent of 20, and to take that 2 and make it an exponent of 10. And that's going to give us log base 5 20 to the third minus log base 5 10 to the second. Let's simplify 20 to the third and 10 to the second. 20 to the third is 8,000 and 10 to the second is 100. So we get this expression. As you can see here, we are subtracting these two logarithms and they have the same base 5. So that means we can rewrite it as a single logarithm. The quotient property will allow us to do that. So we get log base 5 8,000 divided by 100. And we can simplify this quotient here. 8,000 divided by 100 is 80. So we get log base 5 80. And that's our final answer. We rewrote it as a single logarithm, the expression that we initially had. Okay, here's our second example. Express as a single logarithm log x plus 4 log y in parentheses minus 5 log z. So to begin, we're going to use the power property. It's always a good idea to use the power property first if you can use the power property. So that power property is going to let us move that 4, make it an exponent of y, and move that 5 to make it an exponent of z. So we get this expression. We can now move on to focus on what's inside the parentheses. And as you can see, two logarithmic expressions are being added with the same base, so that means that we can use the product property to write it as a single logarithm. So we're going to rewrite this as a single logarithm by using the product property, and that's going to give us log xy to the fourth power, and we can just bring down minus log z to the fifth. Okay, now we have a subtraction of two logarithms here. So that means we can use the quotient property to rewrite this as a single logarithm, and we're going to get log xy to the fourth divided by z to the fifth. Okay, now you try. I want you to express this as a single logarithm. Work well, and I look forward to working more with you tomorrow on these logarithms. If you'd like a hint for what we have here, keep playing the video. If you don't want a hint, stop the video now. Okay, so first you should use the power property here and here. Then move on to what's inside the parentheses to rewrite what's inside the parentheses as a single logarithm, and then I'll let you work out the rest. Okay, I hope this video helps. Take care.